Hello, Soul Carlton, and today what we're going to be doing is that we're going to be doing a continuation of last week's lesson from Factoring Part 1. So if you have not watched the Part 1 video, please do so from last week's posting on Google Classroom. Okay, so from the last lesson, what we talked about is that we talked about factoring with respect to trinomials, which don't really have a number in front. So an example of that would be the one that I would be writing right here. Okay, so if you have something like this, and if you want to factor into two brackets, two binomials right next to each other, again, what you would do is that you would figure out a pair of numbers that would multiply to the last number, being 3, and would also add to the middle number, being 4, right here. Okay, so always the last number and the middle number that you would want to figure out a specific pair of numbers that would multiply to it and then add to it. Okay, so in this case, because 3 is a prime number, it can only be multiplied with 1 and 3 to get 3. Okay, and 1 and 3 would also add to 4, so it checks out in both circumstances. So from last week's lesson, what we can do is just put an x down on both and just simply write, because these are both positive, +1 and +3, and then we are done. Okay, but this week what we're going to be doing is that we're going to be factoring things with a number in front. Okay, so all these questions we're going to be doing today have a number in front of it, the x squared at least. Okay, very, very different, and it's a little bit more trickier. Okay, but I'll walk you through some of the examples. All right, so the first way that we can do factoring with trinomials with a number in front of the x squared is that we can divide everything by this number right here. Okay, so what we can do is that we can divide out that leading coefficient of 2. Okay, so I can factor that 2 by putting a 2 here and then putting a really long bracket. Okay, and what I do is that I divide everything else inside by 2. Okay, so 2x squared, if I divided out that 2 and pulled it out, now it becomes an x squared. Okay, now I have to divide that -10 by a 2. -10 divided by 2 is -5. Don't forget the x because it's carried over. What's 12 divided by 2? 12 divided by 2 is 6, so I put a +6 here. Okay, and essentially all I did once again is pulled out a 2 from every single one of these terms. Okay, so 2x divided by 2 gives me x squared. -10x divided by 2, that gives me -5x. 12 divided by 2, that gives me 6. And now what we do is that we factor out the remaining terms inside our bracket. Okay, so this is equal to that. Make sure to keep our 2's. Okay, what we can do now is just carry on with the tactic from before. Okay, where we find two numbers that would multiply to our last term and add to our middle term of -5. So why don't we do that? So we want two numbers that would multiply to our last term of +6, okay, and add to -5. Okay, so what are all the numbers that multiply to 6? There's 1 and 6, 2 and 3. We can do 3 and 2, and then 6 and 1, I believe. All right, so which pairs of these numbers can we use to make a 5? Well, we got 2, but they're more or less the same. We got 2 and 3, and 3 and 2. And these two are just the reverse of each other. They can make a 5, okay? So what I can do is that I'll put a 2 here, and a 3 here, a 2 here, and a 3 here. All right, so 2 and 3, they can multiply to +6, but 2 and 3, they don't add to a -5. So what I need to do is add my negative signs, because -2 added to a -3, that makes a -5. -2 times a -3, does that make a positive? Wow, yes it does, because we have two negative signs. And if you remember from one of our very first units that we talked about, 2 negatives is equal to a positive. Okay, so everything checks out in this corner. Okay, so once again we copy down our x's, okay, and we put down our -2 and our -3, and we are finished. Okay, so really all the things that is new from last lesson from last week is that we really only have to divide out the extra number in front, and this number can be negative. Okay, so make sure to always remember that whatever this term is, whether if it's a negative or positive, make sure to always divide it out. So for this next question, we would have to do the same thing. We divide out everything by -3 while just copying down this number, okay? So make sure that when you divide things up, always put that number in front of the bracket. Because if you look here, my 2 didn't disappear. It's still right next to it, okay? So what's -3x squared divided by -3? That's just a singular x squared. 36 divided by -3, okay? That would be -12x, okay? If you're not comfortable with doing regular calculations, what you can do is actually, let me grab my trusted calculator, okay? So because this is a positive 36 because of the plus sign, and this is a negative number, when we take a positive 36, I'm using my calculator, and I divide that by a -3, okay, that gives you a -12, okay? Hope you could see that on my calculator. I copy that down and do the same thing. What is a -105 divided by -3? Again, I'm going to take my calculator, -105 divided by -3, and I believe that gives me a positive 35, okay? And now for the next step, I copy down my -3, make 2 brackets, okay? Copy down the x's, and now I need to find 2 numbers that multiply to a positive 35 and add up to a -12, okay? Now these are some big numbers. So what I can do now is that I can actually think of pairs of numbers that once again multiply to 35. We have 1 and 35. We have 2, and I don't think 2 multiplies to anything. 3 can't multiply to anything to get 35. 4 doesn't work. We can do 5, okay? 5 times 7 is 35. And then there's 7 and 5, and then 35 and 1. I think those are all the pairs of numbers that would give you multiplication to 35, okay? So looking at these numbers, it's clearly obvious that only 5 and 7 can ever hope to make a 12. So let's jot that down. Okay, we have a 5 and we have a 7, 5 and a 7, but of course it doesn't add up to a -12. So what I'm going to do is I'm going to take negatives of them. So these negatives, they multiply to a positive 35. These negatives, they add up to a -12. So they both work, okay? So the final answer is -5 and -7, okay? So this is the first technique, and it's called common factoring, where essentially all you're doing is that you're dividing that first number from the entire expression. Now the next technique is a little bit more tricky, and it's called factor by decomposition, okay? And you should only be using this technique if, for example, in this question, you can't divide out everything by that number. So let me rewrite this 5 because it looks a little bit awkward. So we have a 5 right here, right? Now normally you would try to use common factoring, okay? But you would notice that 19 can't be divided by 5. -19 can't be divisible by 5. -4 is also not divisible by -5. So what do? We're going to have to use a different technique this time, okay? This time we're going to multiply the first number and the last number together. So 5 times -4. We're going to multiply those two together and see what number we're going to get. So 5 times -4, okay? And that is equal to -20, okay? So now, instead of finding out 2 numbers that multiply to -4 like we usually do, we find 2 numbers that multiply to -20 and add up to -19, the number in the middle, as always. And this one's a little bit more obvious because there's only one pair of numbers that multiply to 20 and add to 19, and that is 1 and 20. Okay, we can make a 19 by subtracting a 20 from a positive 1. Okay, so if you're still a little bit confused as how to get these exact pairs of numbers, again, what I suggest is to write down all the numbers that can be multiplied to 20. We have 1 and 20, 2 and 10, 4 and 5, 5 and 4, and other opposites. And think about which pairs of these numbers can you use to make a 19 from adding and subtracting. I can't make a 19 from a 2 and 10, so this is not possible. I can't make a 19 from a 4 and 9. Okay, so this is not possible. Can I make a 19 from a 1 and a 20? Yes, because 20 minus 1 is 19. Okay, so it's got to be that number. And then from there, just think about how can I tweak the positive and negative signs such that everything makes sense. Because 1 plus 20 is not negative 19, but if I add a negative sign here, now it makes sense. Okay? Alright, so now we have our correct pairs of numbers, positive 1 and negative 20. What do I do with them? What I'm going to do, okay, is that I'm going to take this middle term right here, this negative 19, and split them into these particular numbers. So before I had 5x minus 19, right? But now I'm going to take this 19, I'm going to split them into plus 1x, okay, and minus 20x minus 4, okay? And essentially, this middle term came from this 1 and this 20 that I already had. So this negative 20 and this plus 1. That came from my pair of numbers, okay? So we don't do the whole thing with, you know, x plus 1 and x minus 20, okay? That's not what we do here. It's a little bit different this time, okay? So now what? Well, now all we have to do is we common factor, okay? So we put brackets, okay, and this, okay, and we basically tried to factor where we can by splitting and cutting the equation in two. So I'm going to add brackets, 5x squared plus 1x, okay, and I'm going to put a second plus sign here. I'm going to split the first and the second into one bracket, and the third term and the fourth term into another bracket, okay? So I've essentially cut the equation in half, okay? We have our first half here, our second half here. Then, what I'm going to do is I'm going to try to common factor out anything I could. So what can be divided by both 5x squared and 1x? I can divide out an x from both of them. So now it becomes a 5x, right? Because 5x squared divided by an x, that just gives me a singular x. A 1x divided by an x, that gives me just a 1, okay? Now I'm going to think about what can I divide out from both a negative 20x and a negative 4. I can divide out a negative 4 from both of them. So dividing out negative 4, we get negative 20 divided by negative 4. That is a negative, a 5, pardon me, 5, and don't forget the x. And negative 4 divided by negative 4, that's a positive 1. Okay? So again, what I did is that I tried to pick out the thing that I can divide from both. And in this case, I can pull out an x from both of these things, right? So 5x, pardon me, 5x squared has an x inside. We can divide out the x from it, and then we have a 1x in it, and we can divide out another x from it. So think about what kinds of things can you pull out from those mini brackets, okay? All right, and the final step, we're almost done, is to actually just look at the repeated bracket, okay? So these two should always be the same, and we're going to copy that down, okay? Whatever bracket you see doubles of, we're going to copy that down, and whatever is left over, we join them in their own separate bracket. So now we have an x over here, that's a leftover, okay? And we have a minus 4, okay? I'll do it in a different color. So we join the leftover items into their own separate brackets, and we combine the repeated terms, because these are duplicates, into their own thing. Okay, so I hope you can see that now. So, okay, once again, the repeated item we put in their own brackets just once, so we got rid of one of them. And in this case, okay, so these are both repeated, I put them on their own bracket. And in this case, we have an x that's left over and a minus 4 that's left over. I just pulled them together and made their own bracket from that. Okay, so this becomes our final answer. Let's do one more example because I know it's a little bit tricky, but bear with me. Okay, we're going to do the exact same thing as before. We're going to take the first term and the last term, and we're going to multiply them. Okay, that's always the first step. 3 times 6, that gives me 18. So now we need to find two numbers that multiply to 18 and add to 11. Okay, so there should be a plus sign. Let's think about all the pairs of numbers that multiply to 18. There's 1 and 18, 2 and 9, 3 and 6. Okay, so which pairs of these numbers can be used to make an 11? Okay, and if you guess 2 and 9, that would be correct, because 2 plus 9 is 11. So we can use a 2 and a 9, and we don't have to change any of these into a negative signs because the signs match, right? Positive 2, positive 9 makes a positive 18. Positive 2, positive 9 makes a positive 11. So it's all good. Okay, and remember, key thing here is that we don't actually do this anymore, okay? This is not what we do now, okay? Because when we factor in using a different technique, we actually split that middle term into that 2 and into that 9, okay? And like you can split one of two ways. You can do plus 2x plus 9x, okay? So you split this middle term into these numbers. The 2x came from this number, the 9x came from that number, okay? And then you write down the plus 3, okay? You can also do it this way as well. It doesn't really matter what order, as long as you make sure you factor out fully all the correct numbers. Like, it doesn't matter if you put the 2 first or the 9 first, you'll get the same exact answer, okay? Now, if we factor it now, the next step is to actually put 2 brackets to cut the equation in half, okay? 9x plus 3. So now we have 2 halves of the equation being added together. The next step is to actually figure out what we can divide from both, okay? What's the biggest thing we can divide from both? In this case, we can actually divide both a 2 and an x because both of these items have an x in them, okay? So 2x divided by 2x, that's equal to 1, okay? 2x divided by 2x is equal to 1. 6 divided by 2 is 3, but also x squared divided by x is also going to leave us with one more x, okay? Because if you remember, x squared is x times x, okay? So x squared divided by x is also x, okay? All right, next step, we can pull out a 3 from this, okay? Because that's the thing we can divide both things by, okay? 3 divided by 3 is 1, 9x divided by 3 is 3, and we carry down the x. And now we have a similar situation. We combine the duplicates into one factor, okay? And we take the leftovers and put them together, okay? So the leftovers are 2x and a plus 3, okay? And voila, we are done, okay? Now, this is a little bit of a longer question to do, but let me know if you have any questions on Google Classroom and message me, and we can have a individual Google Meet if you're having more issues with the questions. So just email me if you would like some one-on-one help with me, and I will gladly set up a schedule with you. Okay? All right, I'm signing off.